Hello guys, very good morning. Uh, so today we will discuss about the basic things for the ADS software. So what is the ADS software and what can we do with the ADS software? What are the things can we do? So that is there. So now I'll try to go to the ADS software. So this is the ADS software. So once you go into the ADS software, you can create a workspace name with your name. And once you create a name, so it appears the window like this. Okay. So now, if you want to create a schematic file, a circuit simulation, you have to click on this and write down your name. For example, I wanted to see some impedance matching, so I'll do the emblem. Okay. I just mentioned this emblem. So now, whatever the tools are there available here, those are there. So now you have different kinds of tools, lump components, okay, basic components. So there are various tools. So simulations, AC, DC, the n number of components, circuit components, where you can simulate them. So that digital also, digital components, analog components, RF components. Okay, so there are plenty of it. Okay, so there's filters also. So there are couple of items and there is this is move button, print, this is to full screen, only the area layout, this is the port, insert port, that's there. So these are the schematic where you wanted to design anything. For example, Hamlin, I wanted to design one microstrip line structure. You can click on this microstrip line, just give length and width, assign the port terminations, terminations. We have termination 1, port 1 and port 2, and you can give them a ground, ground 1, ground 2, and just connect those things. So this is the wire. Okay. Now you have this, you have connected. Now you created a geometry. Now what do you have to do? You have to import M sub. Okay. M sub is the microstrip substrate. Okay. So I'm just trying to make it very simpler to understand. So let's make 20 mil and 3.66 mere each. Conductor thickness 35 micron meter. Oh, where is micron meter? Yeah, 0.0037 is the tan delta. Okay, that's there. Now we finished the uh what do you say, the microstrip subject. Now the S parameter simulation. So we have to keep the simulation parameter also, right? So I'll keep it as 7 to 12 gigahertz. The circuit simulation appears pretty fast. So we'll go for 10 megahertz. So we can go for 10 kilohertz also. Okay, 10 megahertz is fine. So 1 megahertz. That's 5000 items. See, now I have to give this. So width is, so because of the 20 mil, I have to give for 1.11. Length, you can assume 4.5 and apply and okay. Okay. Now just do one simulate. Okay. When you just simulate it, you'll try to create and you just within a second you'll get it. Okay. And now you'll appear a new window where you have this kind of smart chart tools, this kind of a tool, rectangular tool. So these are there. So once you click on this one, you'll appear a box. You can zoom it, click here, and S11, S12, S21, S22. So both. So okay. Now you can see S22 and S11. Uh, there's a marker over here. Just try to keep 10 megahertz. S135 dB, S222 0.04 dB. So it's there. So this is a basic fundamental concept. Okay. Now save it, close it. Now if you wanted to do this in layout, see one method you can directly go here in the workspace, create this layout, okay, and draw there. Okay. But if you want to convert that schematic into the layout, there is one technique called generate update layout. From layout, generate update layout, just click on those and you will have selection. Just apply. Just that's it. You have been created your own emblem. Okay. Now you have created your emblem. Now we have give the termination or the ports. So if you have an idea about HFSS software or CST, any EM simulator software, any geometry, after any geometry, what do we try to do? Assign ports. Okay. So in there we draw a rectangle, but here we just have to click on the arrow mark, click here port one and port. That's it. Simple as that. Okay. Now you assign port. Now do the simulation. We have to do the EM setup. Okay. Just click on the EM here. Create EM setup view. Okay. Now I'll go for MOM. So there is no substrate here. So new substrate. So I'll try to take 20 mil Rogers Rogers material. Okay. How do we select Rogers material? So just click on here. You have aluminum. You have three dots over here. Click on the three dots. Database. And you can select whatever you want. I am going to 4350B. And then just click on 4350B. That's it. You can say include this 35 micron. And this is also there. This is also 35 micron. Okay. Now that's it. You have this close. So frequency plan. Why don't we do it as 7 to 12 gigahertz? As just we did. Output plan, frequency plan, frequency plan. Just simulate. That's it. It's done. Now you can see the new simulation window has come. You can take it again. Click on this. S11, S12, S13. Sorry, S2. Now you can see at 11.5. There's a little deep towards 40 dB in MOM. Okay. So in 10 gigahertz, it's minus 29. I think that would also be minus 29 at graph. So that's there. So now this way you will do the layout simulation. And once you complete the layout simulation, you can now go into the workspace again. So once the layout simulation is done, now you can see the meshing has been done from here. Okay. Slowly I'll try to introduce what is the so we'll see here in this circuit simulation what did and so in circuit simulation we got around 35 dB And in layout simulation, we got minus 29 dB. So there's a difference. Okay. So generally, the layout results will come little less compared to the circuit level simulation. Okay. And because of that, there's no impedance proper mismatch. Okay. That's perfectly matched impedance. So that is one part. Now, uh, so what are there? So I've discussed about the circuit and layout and symbol. So if you want to create any symbol, so it's just you try to create any symbol, and for the circuit, like to add any uh, component in the schematic level. So you have to convert that layout into the symbol. So that is one method. And if you want to add any pin or any IC, create any IC there, you need a symbol. Okay, so new create symbol. So we have plenty of items here. Data items. Okay, so you have like this. You can click on this one. Okay, or auto generate. So if you go to auto generate, you can create the your own symbol. Like it's like creating your own IC kind of a thing. Okay, when instead of drawing before drawing it. So if you want the fashion to be like this, 1, 2, 3, 4, 5, 6, 9, like 1, 2, 3, 4. Generally, the fashion would be like 1, 2, 3, 4, 5, 6, 7, 8. And point of eye length, what is the VI, like the pad to pad spacing, because in the whenever you're trying to create in the layer dimensions, so the pad to pad difference they'll try to put it in the data sheet, so that you can see. And just apply. Okay, uh, existing symbol will be replaced. Okay, that's fine for me. I'll just delete this and see 0.25 dot. Okay, no source or schematic layouts are available to judge. Okay, you need source. Okay, source. Okay, so there are no source on this. Okay, for that, first we need to create the source. Okay, this is the basic things which we try to do. And these are the three things which is important in the ADS. So one is the schematic layout, and other is the layout symbol. And we wanted to do more. So there's tools, RF Pro, there's RF Pro, SI Pro, C Pro. So there's a couple of other things in ADS with this Genesis system view. So slowly I'll try to introduce those softwares, but so currently this is fine enough. Okay, in the next video I'll try to design something or explain you what is passive control window. You can start learning from there. So that is there. Okay. Thank you for watching. Goodbye.